Okay, we're recording, everyone. Ready? All right, so I'm opening back up the file. What you all need to do, let's take a look at the assignment, but what you need to do for Monday is basically, what's due? Page 3, unfolded flat laser cut drawing, kit of parts drawing with labels and numbers showing skin and frame pieces. So I'm going to show you to do that. It's maybe a bit more involved than it sounds, but we're just going to go through that process again. There are two things that you need to unroll, right? Where's my frame? Did I hide it? Here it is. We need to unroll this and this. And this we were able to do pretty easily, like that. So I'm going to quickly show you how to unroll something like this. And unrolling it, flattening it is not the issue, but as my studious student Nicole pointed out, these are intended to slot together. So the intention of digitally fabricating something is that when you're done, you shouldn't be having to use a knife to then cut additionally. You should program all those cuts into your model. And when it's fabricated in the laser cut, you're really just fitting them together. Did you ever use Lincoln Logs as a kid? You know the game Lincoln Logs? That's why you're all architects, because you play with Lincoln Logs. And your brothers and sisters didn't. Here we go. So these are impossibly thin. These have 0 thickness. What thickness chipboard are you going to use? 16th? So we want to give these some thickness. Let's go to our top view. Okay, two things. We'll go over this again. We'll unroll that one more time. But here, let's copy this over. And we're going to do two things. One, we're going to give this some thickness. And then we're going to unroll it. I'm going to show you how to notch these things out, like Lincoln Logs. Here we go. All right. So these are currently, I think we made planar surfaces. Remember that? And then I think we just use the, go to my perspective view. These are the, I think just we duplicated the borders, just the boundaries. How can we get a surface back from a curve? If they're flat, we can type planar surface, right? Because this is a planar curve. Planar. Can you all see it up there? Planar SRF. Okay. And then I can just repeat each one of these. Okay, something about planar surfaces. So you're going to build a model that looks like that, right? Something about planar surfaces. This, I want to show you something. Okay, so this, for instance, you can always go back and forth between surfaces and curves, which is a useful thing to do. So here we have a surface, and how can I extract the curves from this? It's two ways of defining the same geometry. So one thing I'm going to do, I don't have to do this, but I'm just going to explode it. And then you see I have these individual segments. And each one of those is like a twisted surface. What is that called? What's that geometry called? It's fun to say. Let's all say it at the same time. Hyperbolic paraboloids. I didn't hear anyone say it. All right, try it in your free time in your car. All right, look. One way that I can get the curves out of this surface is I can go here. Do you see this surface with a curve and it shows project curves? That's basically your surfaces and curves toolbar. I guess this won't show up in the video. But if you hold it down, you get this menu. Curve from objects. So one, this projects curves on the surfaces. This pulls a curve from a surface. Here you see duplicate edge. So we're going to use two today called duplicate edge and duplicate border. Let me add them to the assignment. add some commands down here. Dupe border. Font says Calibri 10. And dupe edge. Dupe edge. Let's make them all caps. Dupe border. Let's make sure. Okay, so if I type, this one is duplicate edge. So let's type dupe. Yeah, see dupe border and dupe edge. Let's try dupe edge. So look, then I click. I'm selecting these surface edges. What do you notice about these edges? They're all straight, right? They're straight lines. When we unroll them, they become curved, which is a little difficult to comprehend. But so I click those and click enter, and then I can join them. And now I can just delete the surface because it's defined by these edges. Okay, so but the point I wanted to show you is that once you duplicate, so you can do duplicate edge and do one at a time. Click enter, delete the surface. How can I get the surface back using these curves? Hey Frank, how's everything? Did you staple it? Then it's an excused lateness. How can I get the surface back? Bailey. See, this is what I want to show you. This is not a planar surface. Look, it says no faces were made. Curves must form close planar. They've got to be flat. So I'm showing you this because in this case, this is a flat curve. This is a three-dimensional surface. So I can just loft. And look what it's doing. This is what I was trying to duplicate the other day. It's rotating the wrong way. So how can I fix that? I think this is where I can analyze surface direction. It's this command here, analyze direction. So maybe if I flip this one and now try to loft again. Align curves. Did you see what I did there? If I type loft, it's twisting the wrong way. So if I click align curves, and then I click here, click on that point, it flips them. You see that? If I do it again, it flips them the other way. So if you're having that issue, so look, just with curves I can get the surface, and from surface I can get the curves, and I can work back and forth, and I really only need one. So I'm going to delete this, and I just wanted to illustrate that point, that even if I close the curves, because of planar surface, you need a closed boundary. So I'll join them. So look, I have a closed curve, but if I type planar surface, it's not going to work because it's not planar. There are other commands I can do, such as, I think patch is another command. That seems to be having some problems. You can play with these. Jeez, look at that. How can that possibly be coming from that? I don't know. Don't do patch. Anyway, I just wanted to illustrate that we can use planar curves here, but not necessarily for this other one, even though it's all a 16th-inch chipboard. All right, so what we want to do here, I want to cut this piece of 16th-inch chipboard, and I want little notches that this can fit through. So I want to show you how to do that. So I'm going to quickly model the thickness to show you what this is going to look like. So how can I give this thickness? I can extrude surface. Extrude SRF. See, I can give it thickness. And what I'm going to do is offset it in. I can turn on both sides, solid. Let's say yes, it's a solid. And I'm just going to type a 1/16 of an inch. It went out, which really is okay, but let's try to get it to go in. Sometimes you need to type like negative 1/16 of an inch to get it to go in the other direction. You all see that? Okay. This one, I'm going to extrude surface. What direction do I want to go? I want to go both sides, yeah. Now, I think if I do a 16th, it's going to do it on both sides. So I'm going to do a half of a 16th. So I'm going to do 1/32 of an inch. And now I'll come measure the thickness of that by typing distance. D-I-S-T. Yeah, from here to here, it says 0 inches. So my precision is probably set more obtuse than a 16th of an inch. So if I type units again, shouldn't crash your computer like this. Yeah, my precision, 1/8 of an inch. So I want to go down to maybe 1/64 of an inch. Okay. Now if I type distance, right, let's say 16th. Oh, it's only 16th. So it doesn't duplicate it actually. Oh, yeah, it does, yeah. So we want it to be a 16th of an inch. All right, and then this one will offset in, extrude surface. We can click on both to turn that off. So it's just going one direction. And then usually if you just lead it in the right direction and type the dimension, it'll do that. All right, so these have thickness. Let's do the same thing here. 1/16 of an inch. And again, I often, it's a bad habit, but once you do a command, if you just hit enter again, it'll repeat the command. So you don't have to type extrude surface every time, but I should probably just say it for the video. And look, one thing, it offset the wrong direction. So I can either redo it or I can just grab this and move it over. Yeah. And then these, maybe I just want to keep them on their center lines and extrude in both directions. So let's do extrude surface. And type both. And then I'll do a 1/32 of an inch on either side. And then I can select and click enter, enter. Okay? So do you understand the issue now? I want this. I don't want to have to come with my scissors and cut and then measure a 1/16 of an inch and slice that off and then put it back together. Of course, that is how you would do it by hand. And there's nothing wrong with that. I recommend working with a combination of digital and analog methods. But let me show you a project. Have any of you seen this is called the Metropol Parasol Project in Spain by Jürgen Meyer Architects. Can you imagine if some carpenter had to slice all these things off with their jigsaw? And I mean, these things are like, 40 feet tall and sort of 100 feet long. It would be very imprecise, but these are digitally fabricated. Look how they snap together. And you can see each one has a joint, so it slides together, which is what I'm going to show you to do here on a basic level. So this is what we need to do. And one way to do this is to, now we need to use a tool. Right, now that these are overlapping, we want these to overlap. I can either operate on this like this, and I'm going to copy and paste this. So this is the thick version, and then this is the thin version. I'm going to delete the poly surfaces so that I'm left with the two-dimensional surfaces. I'm beginning to think of this class a little bit like some people wake up and do the morning crossword puzzle. You just wake up and do the digital fabrication puzzle. It's a good way to start the day. Okay? So here's the thin version, here's the thick version. And so one thing we can do is, in this case, I'm going to, if we select two surfaces like this and type intersect, see, that is all the overlapping material. So I want to notch out some of that. And I can either here I'm deleting because I've got two surfaces. I have the surface and then the extruded surface with the thickness. And I'm going to try to get rid of some overlapping things. Okay, so I intersected those, so I have this intersected line here. One thing I can do is I can go through and actually type a command called, there are Boolean tools. Are you familiar with Boolean tools? What is a Boolean? What's a Boolean statement? In computation, Boolean, and in mathematics, Boolean operations are true-false statements. So if I do something like this, I think I showed this on the first day. If I do that, and then I do this, and I type Boolean, yes, please. Right, this subtracts from that. That's Boolean difference. And so what I may want to do in this case is use one to subtract from the other. And really I want to use both, either to subtract from the other one. So let's try Boolean difference. I'm going to subtract from this surface with this one, and then click enter. Didn't work. Let's try it again. Subtract from this one, enter. There we go. So I can do that. And what I may want to do is, since it disappears, is I could copy and paste this. Again, do you remember last week I showed you how to quickly hide things so you don't have to go try to select overlapping objects? So I'm selecting the thick ones, hiding them, and then I'm just going to delete all of this and then unhide them. So I only have thick surfaces here. I'm going to copy this again. Okay? So what I'm going to do is use the long ones to subtract from the short ones, and then use the short ones to subtract from the long ones, and then reconnect them. All right, so I'm going to type Boolean difference. I want to subtract from this one, and this one. Enter, using this. Okay, we'll do it again. This one, and this one, using this one. Again, this one, and this one, using this one. One more time. This one, enter. Surface subtract with this one. There we go. One more time. Boolean difference. Select surfaces to subtract from, here, here, and here. Enter. Surface to subtract with this one. Enter. Okay, now if I look at these, there's a little bit of weirdness where this thing is barely glancing these things. And now I'm going to come here just to illustrate this, but I'm going to do it two more ways after this, so bear with me. I'm going to do Boolean difference. Now I want to subtract from here. I could do this all at once. So I want to subtract from these, subtract with these. Believe it or not, it worked. It just might not look like it. Okay. So let's turn these red. Turn these green. And now let's try to put them back together. I'm going to group these because these are now separate objects. So I'm going to select them and type group, so I select them and they all move. And I'm going to copy them. And I should be able to there, I've lined it up. So do you see that these more or less are notched to fit? And so that is a way to model it. It doesn't fit. What in the world? Let's try this again. I think this is supposed to go here. No. Okay, this looks correct here. Why is this happening? What happened? Did I really? And then this one should be here. All right, that looks correct. What did I do, Nicole? I did? Are you sure? Who agrees with Nicole? What did I do? I'll just do it again. What'd you say? I took away from both of them. Oh, I see. Oh, you're right. That makes sense. So I should just line up the middle. So I really kind of messed it up. Listen, okay, you know what I'm going to say, guys? Don't do it this way. It doesn't make a lot of sense. I'm going to show you another way to do it. In principle, you can do that. But I was showing it to you only to show you like you could model it in this way. That's not the most useful way of actually doing this. And I'm going to show you two additional ways. One is pretty simple, and that is to really deal with these in terms of keep them as flat surfaces. And you don't really need to model it. But if you want to do your Make 2D and you want to show material thickness, which when you model things, they always look inherently sketchy and undercooked until you give surfaces thicknesses. Just like if you draw a section, if you draw it with a 0 thickness line, it doesn't look developed or convincing. So do give surfaces thicknesses, and I was trying to show you how to model it. I'm going to do this two more ways. One, with them as a 0 thickness surface, and then I'm going to come back and do it another way to show you a pretty straightforward way of doing this. So the first thing I'm going to do is leave this as is. Let's change the colors again so we can easily follow it. Okay, we'll make the short numbers green. And now we're going to do the same exercise. So copy these down. I'm going to select the surfaces here because I've got curves and surfaces here. I don't want the curves anymore. I can get them back, right? I should be able to get them back. So now just surfaces. So if I click, I'm not having to toggle between surfaces and curves. All right. Now using this, what was the first thing I needed to do? How do I mark where this one meets this one? What is it? Intersect. That's right. So I'm going to take these and I'm just going to intersect everything. Let's try this. Intersect. Objects intersect all of them. Select them all, type enter. And then if you look, you see like a yellow line that shows up. Okay? And then here you see a yellow line. See that line, curve, it stays there. So now when I take this curve, I'm just going to duplicate this. I'm going to start duplicating faces or surfaces and laying them down to prep my laser cutter file. So I'm just going to copy one at a time. Let's use the text tool to label these here. Text. A. Oh, that's big. Heights. Let's do 1 inch. Let's do ½ an inch. Okay, oh jeez, look at that. We 3D print these labels. So I have them as solids. Let's just do curves. A, B, C, D, and E. Okay? So these are, geez. Okay, be careful when you're moving things in 3 dimensions. So I'm going to move them over. Okay, A, B, C, D, and E. We'll number these 1, 2, 3. All right, text. 1, 2, 3. Okay, now come back here and move them over. Where's my number? These are more or less just like modeling notes, so you can identify these later. So let's take A, and let's go lay it down. And so what I'm going to do is select A, and I'm also going to select this curve. So if I hold down Shift and select, it's going to select the curve as well. So I'm going to drag this over. I probably want to drag the letter with it. I'm going to group the different parts of letter A. So I'm going to bring this over here. And now I'm just going to 3D rotate it flat, right? Okay? Now, I'm not going, I'll just do this one at a time. So you can see the surface, and you can see the score mark where the other one is going to intersect it. Which one is intersecting it there? 2. So I might bring this over to label. In this case, it's pretty straightforward, 1, 2, and 3. Although you might get them mixed. You might have this as 1, 2, and 3. So it is semi-important to label these as you go. And this is more important when you're doing something like this. And you've got, 1 through 67. And you need to match rib 67 with rib XXZ, right? Because you have so many letters in the opposite direction. So I do think it's useful to kind of bring all of this with it. You may even want to score these numbers into the part. So this is rib A, and this is 1, 2, 3. I wanted to copy this, not take it. Okay, now we're going to take B. So I'm going to select B, and then hold down Shift. And I also want to select that curve in the middle, and then the surface. And then also B. I'm going to select this and 3D rotate it flat. Okay, continue along. I'm going to take C. Hold down Shift, select that line in the middle. Just going to do it C, D, and E. Is there a line here? Maybe select the line first. Why can't I select it? I see it there. There it is. Shift. Hold this down. Okay. Here's E. Alright, now I'm going to come in here. I'm going to select this. I'm going to 3D rotate it. Okay, so those are my score marks. Now I want to do it with 1, 2, and 3. All right, so this is a little more challenging. I'm going to change the view to maybe X-ray so it's easier to see when I select the curves. Okay, so we're going to take number 1, and obviously it's on the edge, and then I'm going to select this curve, this curve, this curve, and the edge. You can select the curves on the edge, and the number 1. I'm going to drag it this way. Here's number 1. And I recommend that you maybe take the letters. Okay, and I'm going to rotate, 3D rotate this flat. All right, so that's where B hits 1. Okay, we're going to do the same thing for number 2. Select it, select the curve. And select the surface. Copy it over. Rotate it. Okay, now the end. Rib 3. Select that curve. This curve, this curve. Okay. Now I'm going to copy this over. Oh. There's number 3. And the bottom, you know, keep the number on the bottom. Okay, so here's what I want to do, guys. What's important to do is to, if I have 2 surfaces that I want to slot together, I don't want to notch completely out. Then each piece is going to fall apart. So what I want to do is take half from the bottom. These 2 pieces go together. I want to take out half from the bottom of one and half from the top of the other so they slot together and then lock together where you want them to go. Does that make sense? So let me show you this. So if these are our bottoms, A, B, C, D, and E, this is the bottom. And now that I've got this, I could probably come down here, copy it down, and rotate these so that the bottom, you know, sits where the bottom should be. Okay? So A, B, C, D, and E. So what I want to do, I'm going to say all the long members I'm going to subtract from the bottom. And then all of the high members, the cross members, I'm going to subtract from the top. So let me show you what that means. So to do that, all I'm really going to do is draw to the midpoint. So make sure your snaps are turned on and you're drawing to the midpoint. So I'm going to draw from here to here and then over. So I want to subtract from the bottom of that. How wide of a notch do I want to subtract? 1/16 of an inch, so that my 16th inch material fits there, right? So one way to do that is to do this, and then to offset, if I want a 16th, I can offset a 32nd of an inch on either side. All right? So I want to subtract all of this. So now I can draw a frame. Right, that's what I want to subtract. And I can just now type trim. Cutting objects is this. And I can select that. See that? That is going to slot nicely together. Okay? So I'm going to do the same thing here. You're going to need to redefine the midpoint at each section because this is slightly lower than this. If you look at the section of that thing heading through the middle, it's getting taller towards the back. Do you see that? So make sure you have your midpoint turned on. Just snap to it as an indicator and then offset the midpoint, this middle rib is a 32nd. Okay. Now draw your rectangle. And then trim. Use that as your cutting object and then select. Okay? Come through and do each one. Do it a few times. I like to type polyline, snap to the midpoint, draw it over, and then grab it and put the midpoint on the line so that when you offset, (30) on each side, draw a new rectangle. Trim using that rectangle. Okay, you can see how this could take a very long time for something like that, right? But it's your first attempt, so let's do this. There are some automated tools that I'll show you later, but let's just do this manually for now. I still tend to do this manually. Trim. This is rectangle. It's my cutting object. Okay, one more. Polyline, draw it to the midpoint. Move it over. There you go. Okay? Now we could really delete the curves, just to illustrate what it is. You all see this? Okay. All right, and we may want to, copy the number 2. So we know that's the number 2 rib where it intersects. So let's go work on the number 2 rib. So these we subtracted from the bottom of here. So it's going to slot down on top of the 2. So we want to notch out of the top of the 2, all right? So let's do the same thing. So let's draw a polyline. Let's just mark the midpoints. Keep in mind, the midpoints are not uniform, right? Because these are different heights. So let's draw them, move this over. And so now we want to subtract the top half of each intersection. Okay? So we're going to offset 32nd of an inch on either side. We can just go through and do it. Okay. Now I'm going to draw a rectangle. Okay. And now I'm going to just use the trim tool. And I'm going to select these rectangles that I drew to notch out. You see it's missing a little bit here. Because this is not a straight edge like these were. It's not overlapping all the way. So I may want to either extend this curve, just move it down a little to be sure that I'm type move this, staying snap to grid. I'm not shifting the orientation. I'm going to redraw these rectangles. Okay. All right. I'm going to take this, I'm going to draw it there, so it overlaps the edge well beyond where I need to cut. This will avoid all those strange triangular interstitial spaces. So trim, rectangle, trim, trim. All right. I can delete all these. So I would almost recommend you do it like that. It takes a little more time, but for instance, what does the timer mean? All right, I'm going to select these and copy them over. Okay, so now I know, for instance, number 2, let's insert, so C, let's move these over and actually try to assemble them to simulate what they're going to look like. Okay, so here's C, here's number 2, and this is, sorry. Here's number 2. I'm going to move it down here, 3D rotate it up into space. Okay, now let's start with, let's do B, C, and D. I'm going to bring B. All right, so the midpoint of, this is B, remember, sits here. So if I snap to the middle of this cut, I should be able to put it right there. See how that will work? Watch as I'll move it. Okay, watch it here. See that? So I don't, for the purpose of fabricating it, I don't really need to model the thickness, because in the end, if I were 3D printing it, yes, but I'm laser cutting, so I'm only really representing surfaces in 2 dimensions. So this will be sufficient, and then you'll see the thickness of this thing is actually 16th, so you've got a 16th inch clearance there. I do think it would be useful for you to go through and actually model all these slots and then tip it up and assemble it virtually and then laser cut it. You know, we could easily go through and put, let's put C in position there. So let's 3D rotate it. This is C. And this is why it's important to like keep track of which notch is which. All right, and then beyond that, so now we could come in here and to illustrate this point, we could do extrude surface. Extrude surface. Let's go both directions, and we could do 1/32 of an inch. And so you see now this rib has the thickness and the notch built into it. You all see that? We do the same thing here. Okay. So now this and this actually have that. So you could now, for instance, you could 3D print those pieces and they would fit together. Yeah? Does it make sense? So what you need to have for Monday, you need to go through that process so that you can laser cut it. So I want you to draw each one of these ribs. You know, there's not that many notches that need to come out of them. These, I suppose, what you could do is look here, and you could just decide, you know, how do I want to do this? So again, maybe since we're subtracting from the bottoms, I think what you need to do is extend an extra 1/16 of an inch and then trim half of it off on the bottom and trim half of it off on the top for each piece. So to illustrate that point, we would want to do something like this. So I'm going to type polyline, go from here to here, and I'm going to type over 1/16 of an inch. And I'm going to draw it down. Okay, so I've added that much. And now I'm just going to come over and slice that. So because we're subtracting from the top here, I'll do that. So I'll add this to it, right? And then I'll do the same thing over here. And then for A, for rib A, which is going to touch right there, you see that that's going to fit in here. That slot is already here. And then for the ends, let's see, for number 1, we'll do this it'll work out. So add tops and bottoms to the ends of each one of these things. And then do you want to see one more way to do it with, I don't think it's necessary, and it's already 10 after 9. Quickly, I'll show you another way to do it is to take something like this. Let's take this one and this one. And you could do it in place. So what you could do is intersect these, intersect. All right, you get this line. And then what you can do is say, I know that I'm doing a 1/16 of an inch. So I'm going to come draw a square. The length of it is 1/16 of an inch. And the width of it is 1/16 of an inch. Right? And so I can move. If I want to center that here, I can just draw an X through it or a diagonal. So I'll draw a polyline. So I can select this and move it on axis. Right? And so now what I can do is, again, measure to the midpoint. So there's my midpoint. And so I can extrude this up using the box command or the extrude command. Let's do extrude curve. Extrude curve. I don't want to go both directions, no. So I'll come from here to here, and then I'm going to copy and paste this. Okay, I'm going to take it again. And I'm going to extrude curve. From here to here. I'm going to go beyond it. Okay? And so what I want to do now, I can simply just trim the red surface in place. I can type trim. Cutting objects are this square. It's a little confusing. Maybe I'll copy and paste it over here so you can see. All right, so I can type trim. This is the cutting object. Trim it. Let's try Boolean difference. Subtract from here with this. Didn't work. Austin, why is this happening? Hey, welcome to class. Austin is the new TA. Oh, it's not a solid. Here's the problem. I extruded the curve and didn't make it a solid. Let's do this one more time. I think that is the issue. I'm just noticing. So when you extrude the curve, if you're going to do a Boolean, it needs to be a solid. Let's try this one more time. Delete it. Extrude curve. There. See where it says solid? It says no. Let's make it a yes. All right. Now when I do this, Boolean difference, subtract from this using this. Good heavens. Is this solid? You think it's on the edge? Okay, here's what we're going to do, guys. This really works, and it is pretty useful. Instead of starting at the bottom, do like we did, move it to the midpoint. Okay? So you see we have placed it on the midpoint of this curve. Sorry it's jumpy. Here, I'm going to center. Guys, we're almost done. Pay attention. You all see this here? It's on the midpoint of the intersected curve. So I'm just going to extrude curve. I'm going to make it a solid. And I'm just going to go well past the bottom. And then I'm going to go well past the top. All right? Now I'm just going to say Boolean difference. Surface to subtract from this one. Subtract with this one. Jeez. Let's trim. So to trim, I can hide the top one and this one. So I'm going to select those, hide them. I'm going to type trim. Cutting objects, this one. Enter. Oh. There we go. Look at that. It did it. This is supposed to be the easier way. So trim, cutting objects, this one. Enter. Oh, for gosh sakes. There you go. Okay? So that is an easier way if you don't really feel like measuring. You just find the midpoint, extrude up, extrude down, and trim. And you could do that in place. You could go around and do that in place and then lay them down. It's up to you. Does that make sense? It's a little laborious of a process. You'll be grateful when we give you a rib assignment in a few weeks that has like 10 by 10. That's 100 intersecting lines. And we'll show you a faster way to do that. Please complete the drawings and the model for Monday, okay?